All right, homework day 18. We're going to start by writing an equation and drawing a graph to model a real-world situation, of course, because we want to relate our math to real life. It says owners of a recreation area are filling a small pond with water. They're adding water at a rate of 35 liters per minute. There are 700 liters in the pond to start. Let W represent the amount of water in the pond in liters and T represent the number of minutes that water has been added. Write an equation relating W to T, then graph your equation using the axis below. So when it says write an equation relating W to T, it means you're going to have an equation that says W equals something. By the way, this is case sensitive, so you got to use a capital W. So we're trying to find how much water is in the pond. It says there are 700 liters in the pond to start. So we know there was 700 to begin with. They are adding water, so we're going to add water, at a rate of 35 liters per minute. 35 liters per minute. T is the number of minutes. So to show 35 every minute, we would have 35 T. So 700 to start plus 35 liters per minute. Now we want to graph that. So when we're making our table, this is like my x-axis and this is like my y-axis. So I am going to plug numbers in for the T, the horizontal axis, and my answers are going to be the W, the vertical axis, right? Just like we do X and Y. If I'm going to run my water, and I just want to use nice easy numbers. Notice this only goes from 0 to 10. So I'm going to use numbers like 0. 0 is easy to do. If I don't run the water any extra minutes, I just have the 700 liters that I started with. Maybe I want to say that I ran the water for 2 minutes. Well, 35 times 2 would be 70 plus the 700, so 770. Maybe I ran the water for 5 minutes. I would start and I'd first of all have to do 35 times 5. I don't know that in my head. 35 times 5 is 175. Plus my 700 would be 875. Now I only need 2 or 3 points to draw my line, but just for fun, let's do 10 minutes because 10 is easy to do. 35 times 10 is 350. 350 plus 700, 1,050. Now you'll notice when you go to plot these, 0, 700 you can put on there nice, but the rest don't come out very nice. You have to use that plot point tool. Looks sort of like this, and when you click on it, it says plot a point anywhere, and you have to type in your ordered pair, 2 and 770, and the computer will put it on there. I'm just going to estimate 2 and 770. Well, it's a little bit under 800. 5 and 875 would be not quite up to 900. 10 and 1,050 would be just barely over that. And so I should be able to connect my dots. And if I could draw straight, draw my line. Again, I like to do at least 3 points. You can draw a line with only 2 if you had to. But just pick some nice easy numbers that go along with what your graph says here. Number 2 says the Sugar Sweet Company is going to transport its sugar to market. It will cost $3,750 to rent trucks, and it will cost, should say cost there, an additional $125 for each ton of sugar transported. Let C represent the total cost in dollars and S represent the amount of sugar in tons transported. Write an equation relating C to S. So again, relating C to S means I'm going to have C equals something with my S in it. The S is representing the amount of sugar in tons. So it tells me up on that first part, it is going to cost me $3,750 to rent the truck, and an additional $125 for each ton of sugar. Try to make my S look like an S and not like a 5. So again, when I make my table, My horizontal axis is the one I'm going to plug numbers in for. So I'm putting numbers in for the S. My answers are the C's. If I don't transport any sugar, S is 0. I still have to pay the $37.50 to rent the trucks. If I want to transport, let's say 5, it's right in the middle. 5 tons of sugar. I have to take 125 times 5. 125 times 5 is 625. 625 plus my $37.50 is $43.75. If I want to do 10, just add a 0 to the 125, so 1,250. So I'm going to take my 1,250 plus my $37.50, and I'm going to get 5,000. And then I have some points. Again, I probably have to use the plot point anywhere. I'm just going to estimate 0 and $37.50 would be about halfway between 3,500 and 4,000. 5 and $43.75. $43.75 would be a little closer to 4,500. And 10 and 5,000, that one I should know exactly where that one is, so that hopefully when I connect my dots, I can draw my line. Going to look something sort of like that. I'm going to fix my typo here quick. Now number 3 is a tricky one, and that's why I wanted to put this example on here. It says a cookie company uses 1 cup of sugar for every 30 cookies it makes. 1 cup of sugar for every 30 cookies it makes. 1 out of 30. Let S represent the total number of cups of sugar. Let N represent the number of cookies. Write your equation relating S to N. How much sugar am I going to use if I have so many cookies? Well, here's the key part. 1 cup of sugar for every 30 cookies, I'm going to make N cookies. If I multiply this together, I'm going to get 1N or N over 30. So when it uses a phrase like 1 for every, tells me I'm going to end up dividing 1 out of every 30. Now I want to use N and S. Now look at the values here. We want values that make sense, and notice it's not going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want things that make sense. If I don't make any cookies, how much sugar am I going to use? Well, 0 divided by 30 is still 0. Since this has to be divisible by 30, what if I made 60 cookies? If I made 60 cookies, 60 divided by 30 means I've used 2 cups of sugar. What if I use 120? If I make 120 cookies, 120 divided by 30 means I'm going to use 4 cups of sugar. So my table would look something like that. 0, 0, 60 with 2 cups of sugar, 120 with 4 cups of sugar. Connect my dots and draw my line. So watch for that when it says 1 for every. I'm going to be doing something like that. Number 4